My name is Dr. KCH Param, working as a associate professor in mechanical engineering department. Today, I would like to explain different problems on forced convection. In last class, we already discussed the procedure of forced convection. What are the different dimensions? Dimensional numbers are included in forced convection. So, for forced convection, the convection means forced convection. You know that movement of the particles occurs by some external agent. Okay, so the flow either over a flat plate or a circular pipe or any square pipes also. So here condition will say based upon the geometrical position or geometrical construction, uh, there are different formulas are there. So forced convection shows the Nusselt formula is the function of Reynolds number and Prandtl number. You know this one. So for finding Nusselt number, because with the help of Nusselt number, we can find out the uh, H value, heat transfer coefficient. So if you know the heat transfer coefficient, you can find out the rate of heat transfer or heat passing of heat transfer. So through HA into delta T formula, Newton's cooling law formula. So for this one, you have to find out the Reynolds number and Prandtl number. Based upon the Reynolds number, you can identify which type of flow, either laminar flow or turbulent flow. For laminar flow, there are some Nusselt formulas are there. Okay. For turbulent too, the formulas are different. So finally, Nusselt is the constant C R e to the power of m p r to the power of n. So C, M, N are the constants. So L is the just characteristic length. You know this one. This one also depend upon the geometrical construction. Okay. So next, by using these temperatures, temperature of the solid surface and the temperature of the fluid, we can find out the T mean. T mean. By using this T mean, we can take the properties of the fluid with respect to the particular temperature. So T mean temperature. So you'll see some formulas here. We know that based upon the Reynolds number, if the flow is on a flat plate, if the Reynolds value is less than 5 into 10 to the power of 5, that shows the laminar flow. If it is greater than 10 to the power of 5 into 10 to the power of 5, that shows the turbulent flow. Turbulent flow. So based upon the flow, there are formulas C, M, N values are different. So if the flow is laminar flow, so this one is the formula. Nusselt of x is equal to hx by k. So x is the particular distance from starting point to a particular distance. If you take the full length L, so the formula is just double to this one. So hx by k is equal to 0.332 Ra to the power 1 by 2, Prandtl to the power of 1 by 3. If the Prandtl is greater than or equal to 0.6. So this one is the coefficient of friction formula. We have to remember this one. Where x is the distance from the leading edge. So this is the leading edge. You have to remember the starting one is the leading edge. So then Reynolds number Re is equal to rho u x L or x ux rho u alpha into x by nu or u alpha x by nu. So kinematic viscosity. So these are the formulas you have to remember this one. So if you consider the full length, so full length of the plate, so the average friction coefficient and Nusselt numbers is this is the formula double to that one. So Nu is equal to 2 into Nu x. Nu x. So next to this one is the coefficient of friction formula. You know that this is the critical Reynolds number mainly for the flow on a flat plate. So based upon this critical Reynolds number, you can identify type of the flow. So this one is the turbulent flow. If the flow is turbulent flow, then the formula is like this one. So if the Reynolds value is greater than 5 into 10 to the power of 5, in between 10 to the power of 5 to 10 to the power of 7, you can take these formulas. All the formulas are available in data book. You can refer those formulas. So for coefficient of friction formula, so if for x distance, you can take this one. For average frictional coefficient, if you take the full length for the turbulent flow, so you can prefer this formulas. Okay. So we will see some few numericals based upon the forced convection. Then we conclude this lecture. The first one is engine oil at 60 degrees flow. So engine oil temperature has been given. So that is the TFO, fluid temperature is equal to 60 degrees Celsius. Flow over a 5-meter long flat plate. So area of the flat plate has been given, 5-meter long flat plate. So whose temperature? So solid temperature TS is equal to 20 degrees Celsius. Here TFO is greater than TS. Heat transfer takes place from this fluid to solid. So determine the next velocity also given. If the velocity u alpha has been given, means you can understand that flow is that is the forced convection. Okay, so that is the forced convection. In the forced convection, we will see velocity. In natural convection, we will see buoyancy effect. Okay. If the velocity has been given, means we can understand that is a forced convection. The velocity is the 2 meter per second. Okay, so then you have to find the all the parameters, you know that according to Newton's law, to find the determine the rate of heat transfer. So rate of heat transfer Q is equal to HA into temperature del TF minus TS. Okay, area you know that, TF also you know that, TS also you know that. You have to find out the H value. H value has been determined by the help of this Nusselt number. Okay, so Nusselt is the function of Reynolds and Prandtl number. For this one, so you have to find out the Reynolds value. Based upon the Reynolds value, you can identify the type of flow, either laminar or turbulent. So based upon the Reynolds value and flow, you can take the formulas which are associated with the Reynolds and the Prandtl numbers. Okay. So first of all, you have to find out the Reynolds value. Re is equal to, you know that formula, U alpha into full length you are taking L by nu. So you don't know the nu because there is a kinematic viscosity. Then you have to take the properties from the data book with respect to the T mean. So we have to find out the first of all T mean. T mean is equal to TFL TF plus TS by 2. It means 60 plus 20 by 2. It is the 40 degrees Celsius. At 40 degrees Celsius of engine oil fluid. So we have to take the properties. Here you have the properties. So this is the T mean with respect to this temperature. So from the help of the data book, we can take the properties of engine oil at 40 degrees Celsius. So rho is density of that fluid is equal to 876 kg per meter cube. Thermal conductivity of engine oil. So this one is the Prandtl value. Otherwise, we can use Cp by K. By using this formula, you can find out the Prandtl number. Otherwise, the value you can take directly from the data book. So this one is the kinematic viscosity nu. Okay. So then you have to find out the Reynolds value. So Reynolds value formula is equal to U L by nu. U is the given velocity. That velocity has been given 2 meter per second, and L is the, what is the L? So L is equal to 5 meter long, 5 meter long. So by kinematic viscosity 242 into 10 to the power minus 6. So the value is equal to 4.14 into 10 to the power 4. So this is less than 5 into 10 to the power 5. So which is critical Rayleigh number 5 into 10 to the power 5. Okay. So then you can identify this one. You can understand this one. This is a laminar flow. So which is less than critical Rayleigh number. Thus we have laminar flow. The flow is laminar flow. Based upon the laminar flow, and you can find out the drag forces, and you can find out the Nusselt values also. For the drag force, you know the formula CF is equal to this is the coefficient of friction formula. So 1.328 by under root of RE. So by using this formula, you can find out the coefficient of friction. If you know the coefficient of friction, you can find out the drag force FD. So FD is equal to half of coefficient of friction into density into area into velocity square. If you substitute all the values, coefficient of friction value, density value, and area 5 into 1, and velocity square. If you substitute all the values, you can get the value that is nothing but drag force value. So 57.2 newtons. Okay. Now we'll see the Nusselt number. So if you know the Nusselt number, then you can find out the. If you know the Nusselt number, you can find out the H value, heat transfer coefficient. If you know the heat transfer coefficient, you can find out the rate of heat transfer. Okay. So Nusselt formula for the laminar flow for full length. So this one is the formula. Nusselt is equal to HL by K into 0.664. So for full length, X is equal to L. If you take X particular length, then that is the 0.332. If you take full length, means 0.2664 RE to the power 1 by 2 Prandtl to the power of 1 by 3. So you know the Reynolds value, you know the Prandtl value. So Prandtl value we have taken directly from the data book. So Reynolds value you already determined. If you substitute all the values, then you will get the Nusselt value. So Nusselt value is equal to 1918. If you know the Nusselt value, then you can find out the HL by K. This is the formula. By using this one, you can find out the H value, because L is given length. Length is equal to 5 meters. You know this one. So H into 5 meter by thermal conductivity also given. So in the data, so this the thermal conductivity is equal to 0.144. So you can take this one. Okay. So if you substitute all the values, then H value and L value and K value, then you can find out the H. So by using the Nusselt value and L value and K value, you can find out the H value. If you know the H value, then you can find out rate of heat transfer. P is equal to He into temperature difference. So temperature difference is nothing but T fluid is the maximum temperature minus low temperature Ts. So then you can find out H is equal to 52.2 into area is equal to 5 into 1 5 into temperature difference. So temperature difference is equal to 60 minus 20. And you can find out that is nothing but 11040 watts. Okay. So in this way, just you can solve the different numericals. Okay. You'll see boundary layer thicknesses. Here the boundary layer. What is boundary layer? Thicknesses we already discussed in previous class. Two types of boundary layers. One is the velocity boundary layer, that is represented by delta. Another one is thermal boundary layer, that is represented by delta T. Okay. So these are the formulas. Delta formula is equal to 5x by under root of RE. If you know the Reynolds value and the X value, X sometimes particular length, or we can take full length also. Okay. So 5L by under root RE. So by using that formula, you can find out the velocity boundary layer thickness. Okay. So for thermal boundary layer thickness, you can take this is the formula for laminar flow, and this is the formula delta is equal to 0.37 under 37x by under root RE. So this is the formula for turbulent flow. So this is the formula for the turbulent flow. Okay. So we'll see one more numerical which is based upon the thermal boundary layers. So air at 20 degrees Celsius flowing a heated flat plate. So that is 120, 134 degrees Celsius and velocity 3 meter per second. The plate is 2 meter long and 1.5 wide. So you know that area 2 into 1.5. So calculate the thickness of hydrodynamic boundary layers. So first of all, you have to find out Reynolds number. Then you can find out the identify the type of flow, laminar flow. For the laminar flow, 5x by under Re. So this is the thermal boundary layer. Otherwise, just 0.37 in, into x by, and this is for the turbulent flow. This is for laminar flow. Okay. By using this one, you can find out thermal boundary layer thickness. Okay. So this is the numerical. The temperature also given, coefficient of friction also given, skin coefficient of friction at 40 is just you have to uh, calculate the coefficient of friction CFX. Okay, we will see. So x, the distance is given not full length. You can take x is equal to 40 centimeter. At 40 centimeter from the leading edge, you can find out the Reynolds value. Okay, Reynolds value. So this is the plate. The profile is like this one. At distance x, so x is equal to 40 centimeter. Here you have to find out the uh, Reynolds values. Okay, so Reynolds value, you know the formula for u alpha into x by mu, you know that velocity, and x is equal to 40 centimeter means 0.4. Uh, so kinematic viscosity, you can take the properties from the data book. Otherwise, he has the kinematic viscosity value also given here, 15.06. You can use that formula. So boundary layer is laminar because the value we got 7.9 into 10 to the power of 4. So this is less than 5 into 10 to the power of 5. So this is the laminar flow. For the laminar flow, you know that formula 5x by under root Re. Okay. So if you substitute the values, you can find out the thermal boundary layer. Then you know that formula of coefficient of friction CFX. CFX is equal to 0.0664 by under root REX. Okay. So by using this formula, you can find out the coefficient of friction. So in this way, just one more numerical also given. You can refer this one. Okay. So okay. So thank you. These are the different test books. You can refer the test books to solve more numbers, more numericals based upon the forced convection. Thank you listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.